Hey there, it's Andy Bachman again with the Prioritize or Perish web series. This is now episode 7. I'm going to talk about climate models, try to remove some of the mystery about them for those of you who haven't had much of a chance to be exposed to them or think about them. This is definitely a talk for generalists, for lay people, not for, let's say, climate scientists or anybody who's close to them. Just want to make them a little bit more accessible so that when you encounter claims about them, they resonate more, they make more sense, and can maybe inform decision making going forward. I have a disclaimer. Those of you who've seen the show before, basically just saying that the views I'm going to express aren't necessarily those of my employer. Okay, let's get into the deck. Let's not mess around. So before I do the actual climate model thing, just let me say here's some of the motivation for why anyone would really care to go in some level of depth on climate models and what they might mean. This is a excerpt from the National Climate Assessment, the fourth one that came out in 2018, and I've used it in many of my presentations since then. If you read the top part, it says that the energy system is already affected by extreme weather events, many exacerbated by climate change, and it's going to get worse, and with the potential for long-lasting significant outages, it's going to grow and grow. You might notice, though, down in the lower left-hand corner, this just came out yesterday or the day before. This is from NERC, and it basically says, kind of like they did in the summer, now we have concerns that we're going to have enough electricity and enough natural gas to generate power and to heat homes, particularly in the Northeast, but as you can see even briefly there in the small version, not just in the Northeast. So once again, we're playing fast and loose, it seems like, with the grid, and we should be managing it much more conservatively, right? So the bottom of the quote just ends with reliability, security, and resilience underpin just about everything, the economy, civilization, national security, etc., and they have cascading effects into other critical infrastructures if we let that slide. So we shouldn't let that slide. We need to do a better job managing things. And one tool we have for doing a better job are climate models, okay? And we don't use them too much up until now, but we're starting to. When I began this quest to inform myself about climate change and the potential impacts, physical impacts on the grid and other infrastructures, I started doing some digging around. A couple of years ago, I came upon this book. Perfect title for me, right? Demystifying Climate Models, because they were a little bit mystical for me at the time. But it's not elves and it's not fairies or wizards that are responsible for climate models. It's real climate scientists, folks that know meteorology and chemistry and physics and the way different Earth systems work. My objective for this talk is basically to help people understand what they are, what they're not, and once they have those two things, can maybe inform some of their decision making. Again, that's whether you're a national security decision maker, whether you're in a business, or whether you're just deciding where you want to move next, where you want to settle down. So what exactly are climate models? Good question. Essentially, they are just giant computer programs filled with equations and algorithms and data that we improve all the time, the algorithms that we tune all the time based on feedback, and they try to represent inside of the supercomputer these different phenomenon. And you can see them on the right-hand side. As usual, I put the URL down there so you can go into more detail. But imagine trying to capture all those various processes, all of which have effects on each other, and all which vary depending where in the Earth you are and how far forward in the past or the future you want to look. That's what a climate model is. They're produced by national labs or Department of Energy. There's also ones from NOAA and ICAR, and they just are enormously complex, and they require translation. You know, like the Demystifying book, they require people to translate also what the data is showing so that it becomes actionable for regular people. Before I switch slides, just say that the lower left-hand corner gives you a sense for the computational load, right? So if you take all of those different phenomena and more that are on the right-hand side, and you try to plot them over the Earth, that includes overall the surface water, overall the landmass, and then up into different levels of the atmosphere. They end up turning them into cubes. And you can imagine the higher resolution you want to get, the more precise you want your piece of land or air or water to be addressed, the smaller those cubes are going to be. And therefore, you're going to have more and more and more, and modeling the interactions between them. Anyway, to me anyway, without being very scientific about it, that's a way of just beginning to get at what climate models are doing, what they're attempting to do. Up until now, why we have been looking into the future. This slide really should just be called planning. How do we plan? We've looked to plan for the future and all the uncertainties that it holds by looking in the rearview mirror. We say, what used to happen 50 years ago, 100 years ago? How many times has the rain rained this hard or the river been this much over its banks? How many times have we seen the heat reach this level? And so then we call those 50-year events or 100-year events or 1,000-year events. That gives us probabilities. We can use that as engineers and designers for understanding what we need to build, how strong we need to make something, how tall we need to make it, how heat resistant or how big the air conditioning needs to be capacity wise for a given system to continue operating, right? So those have often lived, those rearward looking planning processes in the electric utilities, and others have been called integrated resource plans, and that's what they are today. You can see the word integrated is referring to a bunch of different factors, but when it comes to thinking about the future, they almost invariably and almost exclusively look to the past. It's all we had up until we had climate models. If you look on the right-hand side of the slide, you get some information from Pacific Northwest National Lab in a study they did a couple of years ago. It basically said that when you use the data, the older the data is from the historic record, to understand what you want to do in the future, the less and less valuable it gets. Ultimately culminating in their conclusion that's in bold down there, that if electrical utilities want to do a decent job understanding what they need to plan for the future, they need to think about looking to climate models and not just looking back solely on the weather of the past. How do we know? Sometimes people will say, how do we know these things even work? We can't be in the future, so we can't time travel there, come back and say whether it was right or wrong. Well, cool thing about climate models is you actually can time travel. And for instance, in this case, I think the term is called backcasting. We went back into the past, or these folks at NASA went back into the past. They looked at what the older models from, say, almost 20 years ago in 2004 were telling us about the future, telling us about 2020 or so, right? And then compared with what we see out the window, what we understand to be the weather of the last couple of years, and the temperature range and things like that. And guess what? Yeah, hindcast here on the slide, not just backcast. And it turns out that in most cases, what the models were saying, this is with more primitive models, algorithm-wise, and with not nearly as much computing power, they pretty much nailed it. So that doesn't mean that they'll be right in the future or always really accurate in the future, but it is a vote of confidence, and the climate modelers are doing this all the time. They're checking their work, they're tuning the models based on new information and trying to optimize them over and over and over again. So absent them, all you have is the past to look at, and other than the very recent past, like what have we seen in the last 5-10 years, I'd say it's time to throw out all that older stuff and use the really recent past and present, and then project along the lines of what the models are telling us to have as confident a view we can as the future for planning purposes. One thing you'll note when you start to get into this space is that there's going to be a lot of acronyms, which for people where I'm from in the Department of Energy and the government and the military, it's pretty familiar to them. I guess maybe in the tech world too. But nevertheless, these are new acronyms if you haven't gone into this space, and so it behooves you to have at least a basic understanding of what they stand for. And so I'll do that right now real quick and then overlay on this chart. So the IPCC is the group that comes up with the definitive, authoritative scientific forecasts and for what's coming, and also the rationale for why they think what they do. They've published the sixth iteration of these things last year, this year, and that's called AR6. And I put an asterisk there, so down the lower left-hand corner you can see when the first one and the subsequent iterations were published. And now here we are with the latest, most confident one. The RCPs are the way we used to say, up until very recently, what are the humans doing? How much carbon and methane are we adding? And therefore projecting what we think is going to happen as a result of that additional greenhouse gas load. Recently that's changed, and the term now more common is SSPs, for shared socioeconomic pathways, and that's what you see on this chart. But in many ways, maybe I'm partially wrong, but it basically means the same thing. Like, depending on how much we put into the atmosphere over a period of time, these are the types of temperature ranges we can expect to find ourselves in. Lastly, I put down the COPs, the Conference of Parties. We just had one in Egypt. We had one the previous year in Glasgow. They've been going on for quite a while, and that's where the leaders of heads of state get together and try to come up with different types of pledges so that they can say, my country is going to be net zero by a certain year, 2050, 2060, 2070. And in companies' reports, they're trying to do similar things, reporting to the SEC, reporting to shareholders and insurers and things like that. So that's basically the whole landscape. One more point before I jump off of this is that you can see that we're sort of at a point of divergence, that in the near future, you won't see too much change from where that star is in the middle. That's roughly where we are today at 1.2 degrees centigrade above the industrial baseload. But then if we do a lot or we do a little, if we do nothing, you can see temperatures getting pretty out of hand as you get beyond mid-century. And even by mid-century, you can see some significant results. A couple more details on that right here. So here's your different SSP ranges, right? And what I've highlighted basically are what are considered to be from the IPCC and some others, particularly IPCCs, what they think are the more likely scenarios, right? And then if you go across the top, you see the next 20 or so years, 20 years beyond that, 20 years beyond that till the end of this century. So take a quick look inside that shaded region. It basically tells you that for the next 20 years or so, we're already at 1.2, and you can see some effects, some significant effects from that amount of temperature range. We could go likely to 1.8, meaning we're approaching 2 as we hit 2040. When we get into the mid-century range there, now we're pretty clearly hovering around 2.0 and maybe going beyond it. And then as you get beyond that, now you're starting to be dangerously close to 3 or even going over 3. And I'm not going to try to say what the likely projected effects are. They're not at all good. They're really hard to manage and hard to adapt to. We will adapt, but it will be very challenging for lots and lots and lots of people in the world. What are tipping points? So all of those things in the previous slides, they suggest that the world is, they're positing that the world is relatively stable, that this increase in greenhouse gases is warming the atmosphere, which is warming the oceans and creating global weirding effects, changes in extreme weather and other fast onset and slow onset climate phenomenon. But there are a couple wild cards that we have to acknowledge, and those also go by the name of tipping points. And what I'm showing you here, and I got the URLs down in the lower left-hand corner, is that there's certain places where if the temperature warming, the warming that we're having, causes certain glacier sheets to melt or completely melt, then we're going to see sea level rise. If we see beyond what is projected right now with a relatively stable situation, in the center middle of the slide, there's methane stored in the oceans, especially in the Arctic region. And if vast amounts of methane are suddenly released because at a certain tipping point temperature, the ice is melted and it gets loose. And this isn't just in Siberia where it's popping up out of the permafrost, but also out of water up in the Arctic. Then a lot of these estimates could be off. And we may find ourselves suddenly in a much different world than are projected on on the previous slides. You get down to the bottom here on the text, just says many more are likely as we get warmer and warmer, it's more likely we'll hit tipping points that from which most folks say it's unrecoverable. You can't you can't now do anything super constructive once you hit those tipping points. Applications. This is one thing that I said earlier, that not just to better inform you of what climate models might mean for you and how to make sense of them and put them to. Here's the slide that's about putting them to good use. I just wanted to let you know some of the places where they are being put to good use, and if you visit them, you'll find some of the applications of them. Without going into really hardly any detail, I'll just say that some of the labs that I mentioned that are working the climate models are doing good things with that data. That EPRI, one of the trade groups in the United States that does research and development for the energy sector, they have a multi-lab program. A multi-utility program. I think there's 12 of them or so called READY, and they're starting to look at how can utilities make good forward-looking use of climate data. Argonne is one of the labs that I work most closely with, and they've got some great programs, again, where they are climate model specialists, but they're starting to really bring it to industry. I know they have recent partnership with AT&T in the communications sector. They've recently revised one of the reports that they've done with them. I've just picked a couple standout utilities that I've crossed paths with that seem to be really on the ball here. Iberdrola in Spain, Denver Water, and Con Edison in New York, motivated from their experience, you'd have to say, with Superstorm Sandy. And then there's some private entities. Some of them I think were startups and maybe still are. Some have been incorporated into larger companies, and I'm showing them here in the upper right-hand corner. These guys are basically doing the translation, taking climate data that's publicly accessible and doing some tweaks to it, some patented tweaks to it, and then marketing those projections to various industries like insurance companies or real estate firms and others. So there are ways to pay for really customized versions of this climate data. That First Street Foundation in the middle, on the upper right, a lot of their stuff is publicly available. And I really recommend, if you're going to go to any of these organizations just to poke around, I'd start there. I have the box in the lower right just to show what Iberdrola is saying to its customers and to its regulators, the types of things that it's been motivated to do and has started on its own initiative in terms of climate and grid resilience. I like all the things that they're saying. If you look down at the very bottom bullet point, I think they have a little brain there, and they're talking about applications for improving the design of installations. So that means that they're thinking about heat, they're thinking about floods, high humidity, and other types of storm events potentially, and designing accordingly or retrofitting accordingly. That's the type of thing that I'm looking for, that we would want to see everybody in critical infrastructure putting into practice. I think I'm almost near the end here. This is a project that I've been working on the last couple of years. Its acronym is ICAR, for Infrastructure, Climate Adaptation, and Resilience. And what I'm trying to do, with the help of many brilliant colleagues, not just at Idaho National Lab, but elsewhere in multiple sectors, is put together a tool that can be used by decision makers to understand, so let's say they have assets that they care about, depending if they're in the energy sector, the water sector, transportation, communications, farms, etc., right? Agriculture. No matter what it is they do, I'd like people, without having to be super engineers, super scientists, to be able to have almost a TurboTax-like interface that helps them understand what's coming and about by when, what kind of forces are coming by when, the things they care about, and then offer them up a palette of candidate solutions for hardening their infrastructure, or hardening their assets, or adapting the functions that they do so that they can still continue to operate with confidence. So this website's live now, and the URL for it is down on the bottom. And I'll be working to help turn that concept, that conceptual framework, into an actual tool that you can drive with a relatively friendly interface. When I say you, I mean generalists, decision makers, people who are in companies, who are in government, who are regulators and financial industries, all those folks. And so that's the aim. I'm going to do that, make some progress on big time next year in 2023. So that's the end. Happy Thanksgiving for those of you in the United States coming up next week. 2 ways to reach me. One will be for sure up and running, and the second one is Twitter, and who knows what's going to be the status with that. And for those of you who follow the Ukraine and Russia battles, where my affinity is for with that sunflower. So Without further ado, I hope that was somewhat helpful for you. It was fun putting it together. I'm still learning all the time about how to make best sense and best use of climate models, and hope that they now could make a little bit more sense for you too. Okay? Take care, be well, stay safe.